You know how to zoom and everything, and you can follow the screen and stuff?
Yeah, yeah.
All right, we are on chapter 7. Page 130.
Nyamka!
You're late.
You're late.
Hey, how do you zoom on this thing?
Explain yourself.
You know how to zoom?
I have no idea.
There you go.
Yeah. Come on, Mac. Learn from the pros.
I remember my mom.
Bone is living tissue. Bone building is far from complete when a baby is born. During growth, from infancy to adulthood, bone is increased in size, strength, and hardness. Also, in different parts of the body, bones grow at different rates. Bone growth is partly in response to stresses that are put on the bone by weight-bearing motion. The simple acts of walking, running, jumping, and lifting heavy objects put strain on bones that results in increased bone density. Trabecular bone is found in the shaft and at the ends of the long bones, inside the spinal vertebrae, and inside the flat bones of the pelvis. In the ends, trabecular bone completely fills the cavity, and its structure transmits stress forces to the shaft. Trabecular bone forms an internal scaffolding network for bone. The trusses and arches found within the trabecular bone provide for the great strength of bone and yet surprising lightness. The arches and trusses inside trabecular bone provide a sponge-like appearance in the bone and also create the opportunity for blood vessels to penetrate the bone structure from the center core, marrow, of the long bone. Bone remodeling is such a thorough process that one's entire bone structure is replaced approximately every 10 years. Once maturity is reached, about age 30, the process of remodeling slows and the loss of bone calcium deposits exceeds the replacement of the bone structure. Beyond this point, it is no longer possible to substantially increase bone density. Over time, the density of the arches and trusses diminishes, and the spaces between them become larger. This process leads to a general weakening of the bone structure. It is a very gradual process and requires decades before any noticeable bone weakness appears. Osteoporosis is the end result of the erosion of the arches and trusses. Osteoporotic bone has much larger spaces between the arches and trusses and is significantly weaker than normal bone. Therefore, it is more prone to fracture. This condition is responsible for many injuries related to falls in elderly people. Women are more susceptible to osteoporosis than men. This is probably related to hormonal influence on bone growth and calcification. Also, dietary intake of calcium and other nutrients, including protein, phosphorus, vitamin A, vitamin D, vitamin K, magnesium, zinc, and copper will influence bone density, in that deficiencies will cause decreases. Finally, genetics have an influence on bone density. Here is the progress of bone loss in a person who has taken some precautions related to osteoporosis onset. Note that as the aging process continues, the rate of erosion of the trabecular structure has slowed, and the end result at age 70 is bone that is stronger and denser than a bone with severe osteoporosis. Strategies for preventing osteoporosis are different for young women and older women. Young women should be sure to meet their needs for calcium, vitamin D, and other nutrients. Physical activity of a weight-bearing nature is also important to maintain bone mass. In postmenopausal women, estrogens, estrogen receptor modulators, and calcitonin can slow bone turnover by binding to bone receptors. Calcium supplementation and regular exercise, especially weight-bearing and resistance activities, are important strategies for older people. Further, since both tobacco smoking and alcohol consumption have negative effects on bone growth, these behaviors should be avoided for healthy bones. In summary, osteoporosis, the weakening of bones due...
All right. So, take vitamins. That's probably a good idea because of all those things that are needed for bone growth. If you're deficient in just one of them, the bone growth slows. So, if you can take vitamins, that will make sure you get all of those things needed. And then keeping exercising, sports, making sure to stay active, and especially in ladies, you might need some calcium supplements or that kind of thing when you get older, because it happens more in women than in men. But you don't want to break your bones. That area that they're talking about, that's called the spongy bone. This area that has all the spaces in it, that's spongy bone, and that's on the inside. On the outside of the bone, completely lining the entire outside, is called compact bone. In that area, the cells, there's more stuff. There's not these open spaces. And the cells are arranged in circles like we saw under the lab, under the scope. That bone slide we looked at under the scope was compact bone, not spongy bone. And the cells are arranged in a nice circular arrangement around central canals. You can see the blood vessels go in here and spread out, so the entire bone is filled with blood vessels. And there's a space in the middle called the medullary cavity, and that's where your bone marrow is. In this bone, this is the femur, it's yellow marrow. Yellow marrow is yellowish in color, and that means that's because it's made of mostly fat. You store fat in the middle of your bones, and it's yellow in color. Now, some of the bones, mainly the pelvis and the vertebrae, the backbones, and I think the ribs and the sternum, contain a red-colored marrow, reddish marrow. And that is where your blood vessels are formed. So there's red marrow in some bones, and there's yellow marrow in others. The red marrow forms the blood, did I say blood vessels? The blood cells are formed in the red marrow. So blood cells are formed inside your bones, and then they leak out of your bones and into the blood. This periosteum is a membrane. Every bone has a membrane surrounding it that can kind of get peeled away, which they've done here to look at the underbone structure. But there's this membrane for protection surrounding every bone. And these epiphyseal plates, those things are where it used to be cartilage, and it's the last part of the bone to form. The entire bone used to be cartilage, but the final parts, these epiphyseal plates, will be the last part of the bone to form. And you can tell if you're still growing by doing an x-ray and looking at these epiphyseal plates. If they're still made of cartilage, you're still growing, and the bone can continue to get longer. But if they're made of bone, then you've stopped growing, and you won't get any taller. Mine stopped a long time ago. Because I'm short. You see, that was a short joke. I'm not short. I'm really just far away. I have all kinds of jokes that y'all don't care to laugh at. Oh, by the way, diaphysis, that's the middle of the bone, and epiphysis, that's the end of the bone.
The human skeleton is divided into 4 classes based on shape: irregular bones, flat bones, short bones, and long bones. The femur is an example of a long bone. It is composed of both spongy and compact bone.
So there's spongy bone on the outside, compact bone on the outside, and spongy bone in the middle. And that makes it, the spongy makes it real light. Bones aren't really that heavy. Bird bones, and especially, are real light because they're almost all spongy. They have very little compact bone at all. If you ever find a bone laying around, you want to see if it's a bird bone, throw it in the water. If it floats, it's probably a bird bone. There's kind of a look at it. Spongy and compact. And then if you notice here they've cut out a section of it, and they're looking at it under the microscope. Do you recognize that?
Yeah.
That's what we saw under the microscope, right?
Yep.
The cellular arrangements. The cells of bone cells are called osteocytes. An osteocyte is a bone cell, and it sits within a little chamber here. If you remember, it was called a lacuna. And they sit kind of in this circular arrangement around a central canal. And the central canal contains nerves, which is the yellow thing, and blood vessels, which are the blue and the red. And so every bone cell can get nutrients from this central canal. There are tiny little smaller canals branching out, taking the blood and nerves through tiny capillaries to each cell. So each cell is next to a blood vessel so it can get nutrients. So the bone is a living tissue. And here's a close-up looking at these cells. Here's a bone cell here, you see. And the bone cells, what they do is they remove calcium from the blood and they store it in these spaces here. And so these spaces will fill up with calcium. And calcium is a hard substance. Phosphorus is another one that's stored in your bones. Calcium and phosphorus are what make the bones hard. And see, that calcium and phosphorus that's stored here in the bones is used to help move your muscles and allow your nerves to fire. So your muscles and nerves can't work without calcium and phosphorus, you see. And that's stored in the bones. So if you're running low and you hadn't eaten in a long time, but you still need to work your muscles and think, you know what's going to happen? To get the calcium and phosphorus to run the muscles and nerves? It'll come from your bones. It'll be taken from where it's stored here and moved through the blood to the muscles and nerves to get them to work. You see? It's all falling into place. That's from The Simpsons. I'm a big Simpsons fan. Hey, there's a little fetus, and you can see the red color there. That's all cartilage. The entire skeleton is made of cartilage when the baby is a fetus. And you can see how here's the entire bone is originally cartilage, and the cartilage starts to change into bone. And I don't know if you remember from looking at the cells, cartilage has cells encased in these little spaces just like bone does. But you can see how it kind of changes and gets longer. And then, like I said, the last things are these epiphyseal plates, is what they're called. And when those finally change to bones, you won't grow, and your bones won't grow any longer. So you're as tall as you're going to get. That usually happens around 16 to 22 years old. You guys are getting about there. You're not going to grow a whole lot taller. There's still cartilage on the ends of the bones. It's called articular cartilage. And it cushions the bones where the joints are. There's some down there. So this is the leg, the femur, and that cartilage helps cushion where your femur joins your hip. Your hip bone kind of sits right here, and it's cushioned there by the cartilage. Have you ever heard of anyone who's had a knee injury? They say they got torn cartilage in their knee. Ever heard of that? It's where this piece of this cartilage, because when you're running or something and you have a bad injury, the bones hit each other, and a piece of cartilage could get knocked off, you see. And that cartilage could be floating around in the joint and preventing the joint from working correctly. Often people who've had cartilage damage, like they say they can't straighten their leg. It hurts to straighten their leg all the way, or even they can't do it. It's because that little piece of cartilage that got knocked off the end of the bone is in the way and keeping the joint from turning all the way. So it's stuck, and the doctor has to go in there and pull the cartilage, little piece of cartilage out. Over a lifetime of running and playing ball, being an extreme athlete like I am, you're going to kind of wear away the cartilage at the end of your bones. Just by normal activity, it's just like just like anything else, if you got some jeans and you're always sliding around on them or something, eventually those jeans will wear away, right? And you'll be left with a hole in your jeans. The same thing happens with the cartilage. From a lifetime of playing sports, that cartilage wears away, and you're left with no cartilage on the bone. And when you're old and there's no cartilage cushioning your bone, and if you start getting bone-to-bone contact, it'll swell up really bad. And that's called arthritis. And that's what you get when you're old. Most people get it from a lifetime of playing sports and walking around, and you eventually rub all that cartilage off, and then it swells up, hurts really bad. And that's arthritis. And almost all old people have it to some extent. The more injuries you've had during your athletic career, the worse your arthritis will be when you're older. I had 2 bad knee injuries, ACL replacement surgeries on both knees, and I already have arthritis, and it hurts. And you can take medication and stuff. You can take Aleve or something like that, reduces the swelling and makes it not hurt as much. But it just gets worse. It's something that never gets better. It's part of what's terrible about getting older. Then you have to look forward to it. I'm sorry, I can't do anything about you getting old. Look, see that's not completely bone yet. There's still cartilage there, so this kid's still growing. Huh? Cool, yeah. And so the doctor can take an x-ray and see how wide that area is and estimate how much longer you're going to grow. Go ask your doctor how much longer you're going to grow. They'll probably take an x-ray and charge you several $100s for him to tell you. Want to see some x-rays? They have these x-rays, 3D x-rays, because they take the x-ray from all different angles now. You can see the heart in there. What they'll do is they'll inject you with a substance into your blood that makes the blood vessels and the heart show up on an x-ray. So they can get a look. There's just the blood vessels there. The computer can remove the heart from the x-ray. Pretty amazing what they can do nowadays. And this is a computer rendering of the same thing. That's the heart. Hey, and there's a head. There's the skull underneath. The computer technology with x-rays and such is pretty amazing nowadays. They're looking at this guy's whole skull here. And that video is 20 years old, so they've got a lot better stuff now. MRIs and all sorts of things. Here's what happens if you owe me money. The break, there's different fractures that you can have. Green stick, fissured, comminuted, transverse, oblique, spiral fracture. That's when you get twisted this way. It shows you all the different types of bone fractures on page 136. And how a fracture heals on 137. Here's how it heals. This is kind of interesting. This blood vessel is broken, you see, and it bleeds into the space here. And you form a big blood clot right there in the middle of the bone. It's called a hematoma. Have you ever heard that word before, a hematoma? It's a bunch of blood just kind of sitting in an area. And it'll clot. It'll form like a big scab. And this big scab here is slowly replaced by bone. There are special cells in your bones. They're called osteoclasts. Osteoclasts. Osteoclasts are bone-building cells. They'll crawl around in the blood in this area here and build new bone. Just piece by piece, they'll rebuild the structure of the bone. So osteoclasts are bone-building cells. You also have osteoblasts, which are bone-destroying cells. You have crawling around in your bones bone-destroying cells that squirt out a little bit of acid that breaks down the bone, and then a bone-building cell will come behind it and squirt out new calcium and new phosphate that makes new bone. So your bones are constantly being broken down and rebuilt, even right now as we're talking. And like they said in the video, about every 10 years, your bones are completely remade. I mean, it's a slow process. It takes 10 years to remake a bone, but it's like taking a house apart. You take out a brick here, and somebody comes in and puts a new brick in. You take out another brick here, and somebody comes in and put a new brick in. After doing that for 10 years, you got no brick is the same as 10 years ago. You've got a whole new house. But it's just piece by piece, you see. It's not all at once. Isn't that cool? So when someone asks you how old you are, you go, I'm less than 10.
You said osteoclasts are then building cells?
Osteoclasts are building. Oh, I got it backwards. Osteoblasts are building. I'm sorry. Thank you. Osteoclasts are destroying. Blast, build. It would be better if it was the other way, because blast would be like destroying a blast, but it's opposite. It doesn't work out for us. Okay, so read. I want you to read through 7.3. Yes, read through 7.3 tonight, and there'll be a quiz on that. 7.1 to 7.3. So we're just doing IDs for the rest of the time today. Peace out, man.